Assalamualaikum and very good morning. Today I will present my final year project, which is the title is Investigation of Vehicle Performance and Exhaust Emission Palm Oil Biodiesel Blends under High Load Condition. And my supervisor is Dr. Muhammad Dorizam bin Muhammad Jaad. The content of this presentation will include the introduction, which is study background, problem statement, research objective, scope and significance of study. After that, literature review, which is include summary of literature review. After that, methodology, and then result, which is the result include performance and emission of B10 and B30 biodiesel blend. This chapter will present the introduction for the study. For the study background, fuel is an essential component of the economy and of the development. When fossil fuels are burned, they emit different gases. But biodiesel is more ecological responsibility. They can be made from any organic substance, including waste, and they may minimize exhaust emission. The objective for this study is to evaluate vehicle performance in terms of brake power, torque, and fuel consumption using B10 and B30 palm oil biodiesel blends under high load condition. And the second objective for this study is to measure exhaust emission of vehicle using B10 and B30 palm oil biodiesel blends, which is under high load condition. For the scope of the study, there are four scope, which is the Mazda CX-8 is selected as the test vehicle, and then the B10 and B30 palm oil biodiesel blends. The third scope is Unitex chassis dynamometer, which is Mustang AWD 150. And the last scope of this study is run the experiment under high load condition, where the engine speeds at 80 km per hour and tested between 50% until 70% load condition. The purpose of this research is to perform examination of the usage of biodiesel, B10 and B30 on dynamometer testing. The study looks at the vehicle performance in terms of brake power, torque, and fuel consumption when used B10 and B30 as an alternative fuel for cars, namely the Mazda CX-8. The research takes into measure the exhaust emissions of vehicles using B10 and B30 palm oil biodiesel blends under high load condition. Mazda's SkyActiv technology is a collection of technologies that cover a wide range of vehicle components, including the engine, transmission, body, and chassis. Mazda SkyActiv D brand design refer to its diesel engine lineup, as shown as the figure below. The engine are meant to be more fuel efficient and develop less emission while maintaining performance. Most of the major issue faced by diesel engine is the emission of nitrogen oxide. However, Mazda technology has overcome this issue by lowering the compression ratio, as shown in the figures below. It reduces compression temperature and pressure at top dead center. As a result, even when fuel is injected near top dead center, ignition takes longer, which is allowing for a superior air-fuel combination, which is this reduced nitrogen monoxide ensure development because the combustion becomes more homogeneous without specific high temperature zones and oxygen deficiency. This chapter to present the literature review based on the previous study. The figures below shows the effect of load on the brake power. it shows the brake power increase proportionally versus the load, and the figures for the fuel consumption is shows in the figures below. According to the figures, at distance of 15,000 km and an average speed of 90 km per hour, diesel achieved 17.3 km per liter, whereas butane biodiesel achieved 16.4, using 5.2% more. These values increased by 12.2 with the 5-hole nozzle fuel injector to 18.4. Similarly, conventional fuel consumption reached by 7.5% from 17.3 km to 18.6 km. For the exhaust emission, from the previous study shows the hydrocarbon and carbon monoxide. It shows the hydrocarbon and the carbon monoxide decrease from 20% until 80% percent of the load condition, but after 80% until 100% load condition, it is show that the hydrocarbon and carbon monoxide is increased. Yeah. The high concentration of oxygen in fuel increase the oxidation of carbon monoxide and unburned hydrocarbon, which is reducing carbon monoxide and hydrocarbon emission. There are a few apparatus and equipment that are used in this experiment, which is OBD2 scan, gas analyzer, which is Bosch BEA 060, and then biodiesel blend machine and chassis dynamometer. The table below shows the result for performance for B10 and B30. In range load condition, 50% until 70%. The brake performance include the engine torque, engine power, brake mean effective pressure, brake specific fuel consumption. On increasing the load, the brake power upsurge for B10 and B30 blends, as indicated in the figure above. It illustrates the comparison of brake power for B10 and B30. The peak brake power was obtained is 36 kilowatt at 70% load condition for B10 and B30. The lowest brake power is 23.67 kilowatt and 24.67 kilowatt for B10 and B30 at 50 percent of load condition. The engine reacts to an increase in load by producing more power in order to keep up with the load. The braking power is representative of this higher power output. This figure shows the brake comparison between B10 and B30. The brake torque increases when load increase. The highest torque for B10 and B30 was achieved is 206 Newton meter and 207.67 Newton meter at 70% load. There is 1.67 Newton meter torque difference was obtained. The lowest torque for B10 and B30 is 141.67 Newton meter and 151.3 33 Newton meter at 50% load condition. This is because of the calorific value effect, which is the decrease in brake torque for higher biodiesel blend. In conclusion, both brake torque for B10 and B30 is directly proportional to load condition. However, biodiesel blend is inverse proportional to load condition. The figure below represent the B map with respect to load. The B map was found to increase with increase in load for both tested fuel. From the graph, the maximum peak is 1191.22 and 1181 for 0.66 kilonewton per meter cubic for B10 and B30 at 70% load condition. The lowest BMAP is 868.8 kilonewton over meter cubic and 868.8 kilonewton per meter cubic for B10 and B30, which is at 50% load. The differences between BMAP are caused by the energy content, viscosity, and brake torque. In conclusion, the BMAP increase when load increase. The figure shows the variation of brake-specific fuel consumption for B10 and B30 with respect to load. From the graph, it can be shown that the lowest BSFC is 221.70 and 226.18 at 55% load and 50% load condition, while the highest peak at 70% load, which is the 303.67 and 293.96 for B10 and B30. This is show that B10 is higher than B30, which is higher 9.71. This is due to the lower Stator number and lower oxygen level, which is B10 have 57.2 and B30 is 58.2. B10 may be more incomplete combustion, which would decrease combustion efficiency and increase fuel consumption, which is increasing BSFC. The table below shows the exhaust emission for B10 and B30 at 50% load until 70% of load condition. The figure shows and illustrates the variation of carbon monoxide emission for B10 and B30. The highest carbon monoxide emission are 0.007% and 0.001% respectively at 50% and 70% load condition for B10 and B30. From the graph, CO emission decreased for B10. However, the CO emission are increased for B10 at 70% load, which is 0.001. The decrease of CO emission caused by the presence of enough oxygen leads to improve combustion. Observe that higher concentration biodiesel blend have a higher oxygen content, which creates more effective burning and lower the amount of carbon dioxide released into the exhaust. The figure below illustrates the comparison for carbon dioxide for B10 and B30. The carbon dioxide increase when load increase, but after the load condition reach the 70% load, the CO2 decrease after the load increase. The highest peak for CO2 was obtained is 9.77 9.77% and 12.549% volt at 65 load condition for B10 and B30. In simple term, they form CO2 and water vapor. Under perfect condition, all the fuel's carbon has been converted to CO2 by oxidation, or the combustion process is complete. That's all for the CO2 emission. The figure below illustrate the hydrocarbon emission for B10 and B30. For your information, hydrocarbon are the result from the unburned fuel, which is incomplete combustion of the fuel. The hydrocarbon trend is decreasing. The trend of hydrocarbon is increased for 65% and 70% load condition. And the highest hydrocarbon is 2.00 and 4.522 for B10 and B30, which is at 50% load condition. Additionally, it was said that a greater certain number was the cause of the decrease in hydrocarbon emission. However, hydrocarbon increased relatively due to the low certain number and oxygen content, which lead to incomplete combustion. Figure below illustrate the variation for nitrogen monoxide for B10 and B30 biodiesel blend at different load condition. The highest peak is 40.503 and 69.323 at 70% load condition for B10 and B30. The nitrogen monoxide emission was found to increase with increase in load for both tested fuel. This is because due to the higher oxygen level, because there is more complete combustion and a higher combustion temperature, which is the reasons for nitrogen monoxide emission. Additionally, a larger droplet size and shorter ignition delay during biodiesel injection contributes to its greater viscosity and increased nitrogen monoxide emission. That's all for the nitrogen monoxide emission. This is for my Gantt chart for PSM 2. That's all from me. Thank you.